Hello everyone. In this session, we are going to start the fourth unit. As the part of that, we are going to cover the convolutional neural networks in the coming 2 to 3 videos. So this is the overview of the fourth unit. So in this, it is starting with the major architectures of deep neural networks, unsupervised pre-trained networks, and then convolutional neural networks, recurrent and recursive neural networks, and then most of the topics are based on the convolutional neural networks. So we are going to cover all these concepts. First, I am taking the CNN and related topics, and then we can go for the other concepts. So, as we know, in the regular artificial neural networks, we are handling the images. Already we have done one program also to take the image and convert that into 32 by 32 and flattening it. After flattening, we are submitting that input into the artificial neural network, and then it is going with through various layers, and finally it is going for the output unit, which is having how many number of target labels, those many number of units will be available in the output unit. So we have done already. Now here we have, this is described here only. So the pixels are representing here x1, this is x1, and then x2, x3, x4, and so on. After completion of this column, it is going for the next column, representation of the next column, and then next column. So it is representing all these pixels column wise here. So total here in this example, it is the 16 by 16. So 256 inputs are there. So all these inputs are flattened image. We cannot give the two-dimensional image into the ANN. We have to make it flattened and then provide this. And you can observe that here also. Here there are two major problems in the artificial neural network for handling the images especially. So see here, the first problem is explosion of the weights. How the weights are increased if you increase the number of layers. Let us say, for example, in our previous example, we have seen that 16 by 16 image. So it is 256 pixels are there. So we need 256 weights required in the first hidden layer. In the first hidden layer, we should have 256 weights plus how many number of neurons are there, those many number of bias. So that is the requirement. If you increase the number of layers, obviously the number of weights will be also increased. So in this way, for some type of problems, we have to add the hundreds of layers. In such case, there is the weights explosion, meaning that so many weights are generated. By using the gradient descent in the back propagation, we have to update huge amount of weights. So it is very complex. So we have to find a solution to reduce the number of weights. That is the first problem. And the second problem is, if you observe this here, if you take this pixel, you can please concentrate on this mouse pointer on the screen. So here at this place, if you consider this pixel can be analyzed individually, and at the same time, if you want, you can analyze this with the previous pixel or next pixel only, because it is the flattened image. So but this pixel may be getting affected by the surrounding pixels of 8 pixels. For this pixel, there are 8 surrounding pixels. It may be affected by any one of them. So in the regular artificial neural network, we can consider only the previous pixel and next pixel, meaning that only 2 pixels we are able to handle and analyze, but we cannot handle the 6 other pixels which are on the top and bottom. So we are losing that analysis. So this is another problem with ANN. So we have to handle these two. We can handle these two problems by using convolutional neural network. So the convolutional neural network, it was invented by Jan LeCun. He is the professor of computer science in the New York University. So he introduced a new concept called the convolutional neural network. I have provided the links for reviewing all the concept of convolutional neural network. You can go through that for detail. And the terminologies. Before going into the concepts, we have to concentrate on the terminologies used. In the convolutional neural network, the first point is the filter, that is also called the kernel and the feature detector. The filter means it is a small matrix. We can say that simply it is a small two-dimensional matrix which can analyze the entire image, meaning that instead of taking the number of pixels as the weights and inputs, instead of that we can take the minimum amount of weights. Let us say for example 3 by 3 matrix. If you take the 3 by 3 matrix, maximum it is the 9 weights. We require 9 weights. These 9 weights will be shared for the entire image analysis by using the convolutional model. So that is called the filter. How many number of filters you want to use, that is up to you. That is depending upon the architecture and the complexity of the model. So number of filters can be also used. So filter means it is a small matrix which can be running over the image to retrieve the features of the image. And then convolved features, meaning that once the 3 by 3 matrix, 3 by 3 kernel is moving over the image, we will get some output. That output is called the convolved feature. That is also called the activation map, or we can call it as the feature map also. There are several terminologies used. So all these represents the same thing: convolved feature or activation map or the feature map. And receptive field. Receptive field means we are taking the matrix and we are placing that on top of the image and moving over the image. So at a particular moment where it is taking, where the matrix is placed on top of the image, that place is called the receptive field. The currently active part which is participating with the kernel or filter, that is called the receptive field. We will call it as the receptive field. And the depth of the network, depth of the layer, that is called the number of filters we are using. We can use single filter only. If you use the single filter, you will get the single feature. But I want to get number of features. So the features can be identified and retrieved by using number of filters. How many number of filters are there? That is called the depth. And stride. Stride means we can move the image, we can move the matrix over the image. So while moving that, we can move that by 1 pixel, meaning that is stride 1. If you move 2 pixels that matrix over the image, then it is called the stride 2, stride 3. That is called the stride, meaning that how many pixels you are moving for every, after completion of every receptive field worked on the filter. After that, how many pixels you are moving, that is called the stride. So these are the basic points you have to remember before entering into CNN. Now you can see that I am giving you a small example with the small simple image. Now you can see that this is the input image. The input image is having 3 by 4 image, and I am taking a kernel means it is the weights only. So 4 weights. I am taking the 4 weights and I want to apply this kernel over the image. So in the initial first step, as the first step, I want to place this kernel at the left corner, top left corner of the image. So in this situation, yeah, here in the first attempt, this is the receptive field. This is the receptive field. The kernel will be placed on top of the receptive field and it will perform the operation. Now how it will perform the operation is A into W plus B into X plus E into Y plus F into Z. So this is the value which we can retrieve by using the kernel placed on the top left corner. Now after completion of this, we have to move this kernel only one pixel, meaning that the stride is 1. By default the stride is 1. So if you move this, so this kernel is placed on the BCFG. In this case, the receptive field is the BCFG and the kernel is all over that. So BW plus CX plus FY plus GZ. So this is the second pixel we are getting. And again we move the next location. Sorry. Yeah, this one. Here, this is the next location. CDGH. Now the receptive field and the result will be CW plus DX plus GY plus HZ. So you can see that. In the similar way, after completion of this, we will move here we reach it at the end on the right hand side. So we have to move down. So where we should move is, we will move again 1 pixel down at the left side. So this will be taken. Now EW plus FX plus IY plus JZ. So this will be the result. And similarly, we will move to here and we will get the one more, and here we will get another result. Now in this case, our input is 3 by 4 and the kernel size is 2 by 2, and the feature map, whatever we are getting the output after applying the kernel over the image, that is called the feature map. The feature map size is, here 2 by 3. It is reduced. Right? So why it is called the convolutional means we are combining the kernel with the input. So convolving the kernel with the input, combining these two. Because of that reason it is called the convolutional neural network. We are using this concept in the neural network in the different levels, meaning the different units and different layers. So because of that reason it is called the convolutional neural network. So I hope you understand with this example. And now what is the convolutional neural network? It is in the same, as I mentioned you already, I explained this, the same text, the same expressed in the text format. Now one more important point here is the convolutional layer. It may be the 2 dimension or 1 dimension or 3 dimension also. We discussed about the 2 dimensionally. 1 dimension, 1D convolutional unit that will handle the previous pixel and the next pixel, meaning that previous value and the next value. And the matrix can handle the current pixel and surrounding pixels. And the 3D convolution is also available. 3D convolution, there will be the number of layers, meaning that one pixel it can access the surrounding pixels as well as the previous layer and the next layer also, meaning that it can handle the surroundings of cube. It is looking like the cube, surroundings of all the pixels around this pixel that can be handled. So that is the 1D, 2D, 3D is also available. And it is a supervised learning algorithm because we have to provide the input as well as the output also. And we can create this convolutional neural network as the multiple layers. So this is what we want to start in this video. We will continue in the next video.